Now that we have completed our math review, I wanted to start off this course with just a brief overview of the roles and responsibilities of the structural engineer. So if you search online for the definition of a structural engineer and what they do, you'll likely get a lot of mixed results. And a lot of those definitions are, in my opinion, pretty lacking. So this is my quick definition of what a structural engineer is and what we do. Structural engineers use their expert knowledge of material behavior in response to loads to ensure life safety and comfort of people. I think that serves as a pretty good definition for the minimum of what a structural engineer does. Of course, the best structural engineers, as I've said before, think like architects and think like other engineers and are able to incorporate a lot more ideas into their design. But at a minimum, structural engineers have a role and a responsibility to ensure life safety and comfort of people. Now, let's dive deeper into the role of the structural engineer, and let's start with what is required in their drawings. So if we turn to IBC chapter 16, we start off with a section here on the construction documents. And this first sentence states that construction documents shall show the size, section, and relative locations of structural members with floor levels, column centers, and offsets dimensioned. Also, the design loads and other information pertinent to the structural design is required to be included in the construction documents. So the role of the structural engineer is to provide all of the relevant information for structural members within the building. And we can call that information the output of their design. Also, structural engineers must provide their design loads, or what they used to generate their design input. So structural engineers provide size, section, relative locations, dimensions of structural members, which would be design output. And they also provide design loads, or design input. Now, where does a structural engineer get their design input? How do they determine what design loads to use to generate their analyses and their final design? Well, they get it from a variety of sources. First and foremost, just as with the architect, the structural engineer receives design input from the owner. The owner dictates the use, occupancy, and size of rooms within the building. They can also provide additional design criteria, such as vibration requirements or other serviceability states, and we'll get more into that later. Next, architects determine the programming of the spaces and the geometry of the building, as well as its orientation, which of course has an effect on the input of the design for the structural engineer. Third, other engineers provide design input, particularly mechanical, electrical, and plumbing, who are placing heavy equipment in different areas. So these engineers need to provide data cut sheets that include weight of the equipment to the structural engineer so that they can incorporate that into their design. And lastly, we have the code. Code, of course, provides minimum design loads. And the specific reference standard that provides those minimum loads is this document, ASCE 7, the American Society of Civil Engineers. And the document is titled Minimum Design Loads for Buildings and Other Structures. So this is the primary source that structural engineers turn to when determining the loads for their buildings. Of course, the owner can always dictate that the structural engineer should design beyond the code. And we'll be looking at this document a little more in future videos. But for now, let's ask this next question. Why does the structural engineer need to include their input in the construction documents? Wouldn't this be sort of like if the architect were required to include all of their precedent research in the construction documents? Or to look at it from a different perspective, why would the general contractor care what loads were used to design the building? Don't they only care about the output? The sizes and sections of the members that they need to buy to put the building together? Why would they care about the input? And this is where it becomes really important to define the role of the structural engineer. So typically in buildings, aside from small-scale projects like maybe some residential homes, the structural engineer of record does not design every structural component in the building. Often, structural engineers will hire outside consultants, just like architects. They will delegate the design to someone else. So for example, connections between members are often delegated to an outside consultant. The structural engineer of record will provide forces or reactions at ends of members for the connection designer to design to, but the engineer of record will not design those connections themselves, typically. Also, facade attachments, for example, attachments of brick veneer or curtain wall systems. Those attachments will be designed by a manufacturer, and the engineer of record will provide wind and earthquake criteria. Deep foundation systems as well are often delegated to someone else, and again the engineer of record will provide the forces. And finally, attachments for MEP equipment. As with facade attachments, the engineer of record will provide the wind and earthquake criteria, but they won't participate in the actual design themselves. Now it's important to note that even though the structural engineer has passed on the role of these designs to someone else, they are still responsible, ultimately, for those designs as the engineer of record. And so, during construction administration phases, the engineer of record will need to review all of the designs from their outside consultants, just as the architect participates in review of designs from outside consultants as well. So the role of the structural engineer is to design and document primary structural components, their design output, and to provide loading criteria to outside specialty consultants, their design input. And the responsibility is to ensure the efficacy of their own work and work done by their consultants. And of course, just as we saw with architects, engineers also have their own ethical responsibilities, given in this Code of Ethics for Engineers document. And you can see that both professions have quite a lot of ethical responsibilities to uphold. Designing and building buildings is, of course, very serious business, and in a very real sense, people's lives are at stake. So it's crucial that we are aware of these ethical responsibilities that we must uphold. And so I will be posting both documents, the Code of Ethics for Architects and the Code of Ethics for Engineers, on Moodle for you to review.